Just to let you know, I will be recording this, and I'll post it on the website. So welcome. I'm Prof. Rhodes, Neil Rhodes. I have taught this course twice here at Harvey Mudd. So once a year and a half ago and once way back in 2014, I guess. My background, just a little bit, I was I guess I've had a jack of all trades in some ways. So I was in a PhD program at UCSD and dropped out to start a software company. Not that it became particularly big, but I never ended up going back. And then I used to work on the Macintosh for quite a while. So I also used to teach classes for Apple. So week-long classes where there'd be, let's say, 15 students, not dissimilar from this, but we'd work from sort of 8 to 5, combination of lectures and labs and do things. And that was very interesting. And combine that with software consulting. So I have been sort of a hands-on software engineer a lot, and I've also kept sort of in the academic world as well. So I taught at UCSD for several years and have taught here at Harvey Mudd. In the interim, from after working for myself for a lot of years, I ended up working at Google for 7 years, I guess. So I worked at Google in their Irvine office. And now this is what I do. So I'm going to probably want to do introductions. Oh, the other introduction I wanted to do was also, I was just going to ask you guys what is something unique about yourself. And so I thought I would start and say that I used to be in a circus. So this was, there's a circus here in town, a community circus, and I was in it for many, many years. It's closed down right now because of COVID. And this was an act from a few years ago, 2 or 3 years ago, called low casting. So it's where someone's on a trapeze flying, and in this case, I'm catching them and they're swinging back and forth. So it's not quite full trapeze because I'm not in a trapeze as well. I'm in a stationary apparatus, and we had some other guys work as well. So that's my weird thing that I do. Let's go back to slides. All right, so today is going to be basically all about logistics. A tiny bit about the fact that I really like operating systems. And I hope you're going to really enjoy this class as much as I do. I think you're going to get a lot out of it. I know the last time I taught this class was a year and a half ago. And although it was a lot of work for students, people really got a lot out of it. Unfortunately, the fact that it only gets taught every 2 years and only to juniors and seniors means we've never have Grooters who have taken operating systems. And so we don't have any Grooters this class, just as we didn't last time. So let's talk first about the course website. So the course website is here. We're going to be using Piazza for out-of-class communication. I encourage you, if you have a question of me, post it to Piazza rather than sending me an email, if you would. And in general, unless it's something that really needs to be private to me, go ahead and post a public question. So if it's a question about an assignment, a question about a lecture, a logistics question, anything like that, go ahead and just post it as a public Piazza. 2 reasons for that. One, the other students may be interested in the answer, and 2, other students may be able to provide the answer, okay? Because I may not be as quick in responding as other people might be. So, and then we have a Sakai Uber site that we're sharing the course website and the Sakai with the other section of this OS class. Okay, so kind of treating it as one big group in many ways. Although our course meeting times on Mondays and Wednesdays will be separate. We do have a guest today. Keizo's actually in section 1, but he had an issue with airplane, something, and so he came to today's. That's fine with me if you on occasion need to come to the other section. That's just fine. If you have any questions, feel free to virtually raise your hand in Zoom. I'm not that great at noticing that. I am working on that as well. Feel free to just unmute yourself and ask the question. That's fine with me too. Let's go ahead and look at the website. All right, so that's pretty amazing.
And also, I don't think we can see the slides right now. We could just see the circus photo.
Oh, that would be a mistake, and I appreciate your saying that. And please, so as we have sort of technical difficulties, or you're seeing, is it showing now? How about now?
Yes.
Yes? Okay, excellent. All right, so yeah, just I have got different technology going than I did in the spring, and so there's always the possibility of error. So just let me know when I am talking about something and seem to be saying that something is in front of you that's not, or if I'm muted, or my video ends, or all sorts of issues. All right, so let's see. So this is the course website. The course website has the schedule, which is probably the most important piece of information. We also have the syllabus. We'll be talking about that in some length. We have some information about labs. This is where a large majority of the learning is happening in this class, so hands-on working on an operating system. We have an actual separate operating system that we'll be working on in class, but not during lab time, called Xv6. We'll look at this in a little more detail. We have a list of references for various things, and then we have the link to the Piazza. So if we look at the schedule, you can see we basically have for every day kind of what we're going to be doing, what preparation you need to do. And you may say to yourself, hey, did I fail to do this preparation? No, I actually need to move this over to Wednesday because you clearly couldn't have known to have done that. There's a handout, in a sense, we'll be talking about this, and I'll show you where it is. If we were in person, I would actually hand you a printed book. For Wednesday, you'll notice the preparation is pre-class videos. So this class runs as what's called an inverted classroom. So what that means is lecture is outside of class and homework is inside of class. Okay, and other sorts of in-class assignments. So you're going to, so I have pre-recorded videos for lectures. You're going to be watching those before class, and then also readings. And then when we come into class, we'll have questions and answers, or questions about the lectures or about the reading, and then we'll have some sort of, usually an assignment, often a group assignment, but some sort of work that we'll be doing. Okay, and so you can see here we have kind of the semester set up. The first, and there are a couple of days where actually what we'll be doing is working on labs in class. So there are, I think, 2 of those, there and here, right before Thanksgiving. So those 2 days are, we don't have scheduled activities, we just work on labs. Questions so far? Anything? Okay. Let me show you videos. So let's see. Sorry, I just need to set something. All right, so the videos, and this is still showing? Yep, okay. So videos are basically a playlist. So every day will be a playlist of videos. The first day has what seems like a lot of 11, and I'll get to the reason for that. There's actually really only 7 of them that are really for that day 2. And you can see most of them are fairly short, you know, a couple minutes, 6 minutes, 3 minutes, 2 minutes, 7 minutes, and then there are a couple long ones, 10 minutes and a 26-minute one. But actually, all told, it's still less than the hour and 15 we might normally have for lecture. And then let me just show you kind of an example of what this might look like. So I can't hear that. Can you hear that? Okay. Why don't we just pretend and assume that there will, in fact, be a voice that goes along with this that's just not displaying right now. Okay. And so that was part of what I spent my summer doing, is setting up the technology so that I could actually, in a little studio in one of my bedrooms. Okay, let's go back to the slides. Okay, so here's where basically everything is. Sakai has basically links to everything. So it has links to the Zoom, it has links to the website, the Piazza. I'm going to talk about these quizzes in a bit, and it has the grade book. As I said, the lectures are all online. We'll have this calendar here. I'll record the videos for the course, and we'll put them up after the, sometime after today, for instance. I'll put up the recording we're doing right now. The lecture formats are basically operating system ideas. The one difference on that is I also have some tutorials. So what I've got up there right now is, let's say, a Vim tutorial, GDB, SSH, Bash, Tmux. And these are all things that will make your life easier. So you may be a Bash user, but I still recommend you go ahead and look at this video, because you'll probably learn a few things that you are not aware of that can make your life easier. Same thing is true for Vim, SSH, Tmux, GDB. Even there, I think you're going to learn. You're going to learn something, even if you are a user of GDB. The goal really is to learn to master your tools. Many of these tools you're going to be using a lot. I'll give you an example for Vim. So I started using a Unix text editor before I think Vim even existed, before VI existed, and then started learning that, and that's back in the early to mid 80s. So my fingers know Vim really, really well, and part of what I've done is made sure to go through tutorials, to read the manuals and so on, to see basically what I'm missing, what I might be learning. So some of these tutorials are showing some kind of nooks and crannies of some of these tools, but these are going to be tools you'll be using for years, and so learn to be expert at them. That's kind of my basic take on these things. Our lectures will have 2 different operating systems that we'll be using. So we have JOS, which we'll use for labs. And we have Xv6, which we'll use in class and in lectures. These are different. They're both fairly small operating systems, but they differ in some significant ways. And we're going to be, in some sense, what this is going to give us is learning about not just one operating system, but a couple different operating systems. And they're different styles of operating systems. we'll talk a little bit more about that today. So the in-class meetings before class, do these things, right? During class, ask any questions that you might have. Although my preference would be that you actually ask questions on Piazza beforehand so that other students can have a chance as they're looking at the lectures or doing the reading to see whether they have also those same questions or might be able to answer those questions. But worst case, you come to class, you have those questions, please ask those. Okay. And then we will often do programming assignments. We'll be working in groups. So these will be ad hoc groups. So I'll just make up of, Wednesday we'll have a program assignment that we do, and I'll just make up some groups of 2 or 3 people, and you'll just work on those then. As you'll see when we get to labs, they have different, more long-lasting groups that'll be used there. When you come to class, since we're going to be doing programming, you need to have a computer that's available to SSH into Knuth. Okay, because you'll need to be into Knuth doing some programming. And also expect that you're going to screen share to your group, right? Or some other group member will screen share to you so you can share what's going on. Okay, is that clear on the class meetings? All right. The in-class program assignments, again, many of them are going to be using this Xv6 operating system. Xv6, historically, we look back at Unix, right? Unix was developed at Bell Labs back in the early 70s, and they made available some different distributions. V6 was the first big distribution that made it outside of Bell Labs. And it was novel for its time because it was an operating system written in a high-level language. So most operating systems were written in assembly language, and it was relatively small. And so an instructor a professor in Australia came up with this idea of producing a commentary on the operating system. So produced kind of this book, which included both the source code to the operating system, right, all the C code and assembly code and headers and so on, and then a commentary that went along with it that described what was happening, referencing line numbers even, right? So on this line number, so what's happening? What does this function do? How does this all fit together? And that was used for instruction on operating systems, so they could actually see a real operating system. It turned out, though, that AT&T didn't want to lose control of their source code and didn't want it to be available just in general. They carefully licensed their source code, and so it couldn't just be available in any in academic settings. And so this book was kind of lost in some ways. It was restricted. It can no longer be sold. And so there was this underground Xeroxing that happened of this book. So I might get a Xerox of a Xerox of a Xerox of a copy of it, right, from someone that was sort of transmitted in the underground. And eventually then it was actually reissued in the 90s as a real book. So Xv6 is naming basically V6 for the x86. So the V6, original V6 was for the DEC PDP-11. Xv6 is for the x86. Most of it is in a high-level language, C, and is actually processor independent. But many parts of it are processor dependent and depend on the x86. Let me show you 2 things. Let me first show you the Xv6 code. So if I look at Xv6 and we look at the Xv6 here, this just gives some basically background and says what GitHub repository you can use to check out the code. Let's look at the printout. So the printout is basically this pre-printed version of the code. It has a table of contents. So you can see, for instance, the exec is used on all these line numbers, okay, 6610, 0275, and so on. Every page of the source code starts on, so every page has 50 lines. So if you can see, there's a page on the left of the sheet that's 50 lines and another 50 lines on the right. So 50 on the left, 50 on the right, 50 on the left, 50 on the right. So that makes it fairly easy to track down what page has a particular reference. And so let's just pick a file here. Let's say this file, elf.h. You can see, has struct declarations, has other struct declarations over here, and then presumably, sorry, this is date.h, so this is a different file. And somewhere in here we have C files too. So here's, for instance, main.c, which ends here and has some blank pages. If we go all the way to the end, you can see we have a total of basically 93 93 pages. So we have about 9,300 lines of source code, which is a relatively small program. And this is basically provides Unix functionality, a subset of Unix functionality. If we go back up and look at the commentary, the book, see what that is. So let me scroll down a ways. We got a bunch of chapters, basically. The first chapter is an introduction. It doesn't talk much about any particular code. So let's go into, let's say, the second chapter. So chapter 2, as you can see, there's a lot of description of page tables, paging hardware, and eventually here we're going to get some references to code. So here, for instance, the flags and all things are defined in menu.h, which is starting at line 0700. We have KV malloc, which is at line 1840. We have a description here of map pages and what map pages does, and it's describing, again, particular line numbers. So it really walks you through the source code rather than just having the source code with a few comments. It's got quite the commentary. So it's the current version, or modern version, I guess I'd say, of the Lions book. Let's now actually look just a little bit at the code here. So I'm on Knuth, and this is Xv6. And let me just make, and we can see how quickly it builds. So you can see it takes about, 15 seconds maybe to build. And we end up with a kernel of about, 200K. So definitely relatively small. I can actually run this thing. And I'm running it. So this kernel is developed to run on a raw x86 hardware. We don't want to be working with raw hardware. So instead, we're going to be using an emulator called QEMU, which is a regular old application that provides what looks like raw hardware. And so that's what Xv6 is going to be running on. So I'm going to go ahead and run on that. For some reason, it's cleaning before it makes. A couple things to note. Notice CPU 1 is starting and CPU 0 is starting, so Xv6 actually does support multiple CPUs. And it has a shell, which has a few commands. ls is one of them. Notice its printing is really slow. So I can catworks. And there are a couple of other applications there. And then the way to exit QEMU is Control-A-X. Don't memorize that. We talk about that in the emulators video. And if I look at, so let me look at how many lines there are. So we have about 11,000 lines. So there's some difference between that and the book. One possibility is it's a slightly different version. The book and the printout, as you can imagine, have to be 100% aligned. And so our version that I've checked out of GitHub might not be exactly aligned to the book. The other possibilities, there may be just some files that were not actually provided in the book. All right, let me go back to the slides. So I mentioned Xv6, and I also mentioned JOS. So JOS is, maybe I didn't mention JOS. JOS is the operating system, the kernel that we're going to be working on in our labs. So we start with a very simple JOS in Lab 1. You'll add some code to it, and then we'll also provide you some actually additional code for you to start working on Lab 2. So we provide starter pieces for most of the labs. So each lab will basically be a combination of the starter pieces we provide you, plus what you've done in the previous lab. So every lab builds upon the other labs. Xv6 is a sort of traditional operating system. It's very similar to a very simple Unix. JOS is a different sort of operating system. The API that it provides to applications is quite a bit different from Unix. It exposes more of the hardware, more lower level features. So that means you can sort of do more of the work in user programs rather than a kernel itself. The kernel can stay smaller. But they're on the same rough size. So Xv6 we saw is sort of 9 to 11K. I guess we could call that 10K. JOS, I think the initial version we give you is somewhere around 4 to 5K. And that's not 45. That's either 4 to 5K. And that'll build up over time. Neither one's as complicated as modern Linux. However, okay, I wish I could zoom in on this. And I don't know why I can't. So I will read it because it's not clear it's readable to you. So this is an email from someone in Helsinki, Linus Benedict Torvalds, 25th of August, 91. And it says, hello, everyone out there using Minix, which was a Unix kind of clone that there was a textbook for. I'm doing a free operating system, just a hobby, won't be big and professional like GNU, for 386/486 clones. This has been brewing since April, so it had been about 6 months, and it's starting to get ready. I'd like any feedback on things people like or dislike in Minix, as my OS resembles it somewhat. I've currently ported Bash and GCC, and things seem to work. This implies I'll get something practical within a few months, or sorry, a few months, and I'd like to know what features most people would want. Any suggestions are welcome, but I won't promise I'll implement them. It's not portable, and it's probably never will support anything other than AT hard disks. That's all I have. So my guess is at that time, this was about in the same order of size as JOS and Xv6. Certainly probably not more than 20K at the time he was writing this post. Now, it turns out over time, Linux has gotten a slight bit bigger and more popular, and is portable, and supports more than AT hard disks. So who knows what you might do with JOS. But one of the reasons we don't, for instance, use Linux as our study is it's just too massive. It's massive in a number. It's massive to build. It's massive to work on. It's extremely complicated. And JOS and Xv6 are approachable. And so that's the reason we work on them. We've got, any questions so far? All right, we've got 9 programming labs. So lab 1 through lab 9, they all build upon the other. So lab 1 goes to lab 2, goes to all the way to lab 9. You can work on them by yourself or in groups of 2, but I guess I'd call pairs. I highly recommend you work in pairs. The pair that you choose need not be from this section. It can also be from the section 1 if you want. But what's important is that you've got 2 of you together. You have some time in common that you can work during the week. And that you're both kind of in the same agreement over the pace that you're going to be working on these labs. The JOS kernel, like Xv6, is written in C. You'll modify and extend the OS by writing. That is left over from long, long ago. You're going to be writing C code. So this is all in C, okay? There's no Java. JOS also runs on x86, just like Xv6. So just like Xv6, for both of them, we're going to be using QEMU as our emulator. These labs we're going to be building up. We're using GCC. We're actually using a version for this course. So a set actually of components, GCC and assembler and loader and GDB, linker, binary tools, and so on. Those are pre-built on Knuth. My recommendation to you is just do all your work on Knuth. If you really want to work on your own laptop, you can. And I've provided a tool guide that shows you how to do that on Linux or on the Mac. But I'm not sure it's worth it, and it's probably worth just using Knuth. If you have some problem with network connectivity or something else, then yes, go ahead and set up those tools. But beware. We have labs. So these labs are going to be shared between section 1 and section 2. So they're both combined on Wednesdays from 6 to 8 p.m. These are going to be run as breakout rooms. So we'll connect via Zoom. We'll separate into breakout rooms based on your groupings. We'll start the first lab on Wednesday slightly differently. And then what you can do is raise your hand virtually if you have a question, and I'll come and join your break room and answer your question. I will also, unannounced, pop into breakout rooms to look over your shoulder. So it will kind of simulate a real-life lab where there'd be a bunch of people in the lab, and I would just walk around from, machine to machine, looking over people's shoulders, seeing what they're doing, asking them questions, offering unsolicited advice, and so on. Okay. These 2 hours are not sufficient to complete your labs. You will be needing to do a fair amount of additional work outside of these lab hours. As well as labs, we also have I have a set of learning objectives for the class. So the things that I would like you to learn in the class. This is an example of one of the 21 learning objective bundles. So it's a set of learning objectives having to do with processes and threads. And this is what I want you to learn from processes and threads. And then I have some assessments to see whether in fact you've learned this or not. These are basically quizzes that are implemented on Sakai. Okay. So the grading consists of 2 parts. There are assessments of labs. Okay, so what happens is you're going to do a lab, and then you will do some automated grading on it. Let me just show you that. So let me go up into JOS. So if I make, let's just see how long it takes to make. So if I make, yeah, that's what I get. If I make Kimu Nox, that'll launch Kimu. And I'm now in the kernel for JOS. And to begin with, it says I can type help to see what I can do. Also notice it suggests, hey, you can use Control-AX to get out of Kimu. But in any case, this is the initial version of JOS, and it doesn't do very much. I can type help, and it tells me, well, one of the things I can do is type help, or I can type kern info. So that's all I can do with it. We'll be adding a lot more over the semester. If I do a word count, I can see, 4,200 lines. So it's really small to begin with. But the other thing you can do for each of the labs, so this is lab 1, it's going to do lab 1 grading. And so lab 1 grading, it does some automated tests. You have access to the tests and see what they are. And basically, you see that lab 1, you've got a 0 out of 50. Okay? You need to fix the lab so that you get yourself a 50 out of 50. Let me show you what lab instructions look like. So lab is fairly long. The initial lab 1 is mostly about getting you building and using Git and things like that. But as well, it tells you, all that you're going to be doing. And you can see somewhere in here, many of these exercises are just looking at things, figuring out what's going on. But there is some programming which comes down to the end of this. Let's see. Okay, here. We've emitted a small fragment of code, fill it in, and there's a challenge exercise. And here, answer some more questions. Implement this function, and then modify it to do this other thing. So lab 1 has a lot less programming than the other labs. But supposedly, once you have done these exercises, then you should be able to complete the lab, you should be able to do a make grade, and it should get you all of the points. So what happens then? Well, this really is going to emulate what happens in the real world. So in the real world, you write some code, it solves a problem, you're adding it, let's say, to a large base of code. You don't just go and commit it. Instead, you do a code review. Oops. So we're going to be doing code reviews for this class. So once you're successfully passing the autograder, you're going to submit your code for a code review. And I'm the code reviewer of all the code. And so I will then, I already know it's passed the autograding, so the correctness is probably there, but there are other things I'll be checking as well. There may be some correctness that isn't checked by the autograder, but more likely I'm looking for things like style. For example, if the JOS code that's there uses tabs for indentation, did you use tabs or did you use spaces? I have something that I apologize for, and that is JOS and Xv6 are different as far as tabs and spaces. I don't remember which one is which, but one of them uses tabs and one of them uses spaces. And so whichever code you're in, you want to be using that same formatting. As well, you want to be following sort of the style of the surrounding code, how they use braces, how they do indentation, whether they have spaces after a function call before the paren, or spaces after an if before the paren, simple things like that. Let's say, for example, in lab 1, we'll have a comment there that says your lab 1 code should go here. When you're submitting your code, should that comment still be there? No, that comment should not be there anymore. That was only for you as an indication this is where your code should go. So in the code review, I might say this is an extraneous comment, get rid of it. Okay. So those are the sorts of things. And I might also have just some sort of code style type things like, maybe you should, this is not a very good local variable name. It's not very meaningful, something else. I would expect after we do the first few of these code reviews for the first few labs that you should know what I'm looking for, and subsequent labs, you'll be able to kind of look through your submittal, see what I'm going to be looking for, say, I better just go ahead and fix that before I send it for code review, and the code review should go pretty quickly. Okay? So we'll have a code review. Eventually, we'll go through the code review, and I'll approve it. As well, we will need to do a oral interview. That is a 15-minute meeting with the team, the group, so that I can ask you questions about the code and make sure both of you understands it completely, okay? We are not using pair programming guidelines here in the sense that you don't have to both be in front of the computer at the same time together to write any code. You can work separately, but you need to completely understand what the other person has done, okay, such that when I ask you questions, you can, either one of you can answer those, right? On all those, if all those are yes, then the lab is complete. If not, you need to redo it until it's complete, okay? So passing automated grading tests, you're not even gonna submit anything until it's passing automated grading tests. We'll go through the code review process, we'll go back and forth until I accept the code, right? Accept the submittal. And then finally, we'll have to talk in office hours. Once that's done, you're done with the lab. Okay, there's no like, my lab mostly works, and so I get partial credit. It's, I have completed the lab and completely got it. And then you can move on to the next lab. That sounds like it's going to be time consuming, right? So I work on lab 1, and then I send it out for a code review. And then we have code review time. And finally, we accept the code review. So the key is you don't have to wait until the accept time to start on lab 2. You can go ahead and start on lab 2 as soon as you submit lab 1 for code review. So you can start work on lab 2. The key is, after your code review has been accepted, you need to merge in your changes to lab 1 that happened from the code review into lab 2, okay? Because again, we might have this extraneous comment that says your lab 1 code here. Since you started work on lab 2 before you fix that, it's still in lab 2. We don't want that to be there. So we'll go ahead and merge in those changes in lab 2. We'll be using Git for this and Git branches. You'll learn how to do it. If you don't already know how to do it, it works well. And this is exactly analogous to how life works out in industry. At Google, this was very common. I was working on a change list, basically something to submit. And I had another change list that was dependent on it. I would work on that dependent change list. This one would change over time, and I have to apply those changes. So it's very simple. So you can do overlapping. One key, though, is you can't submit a lab while a previous lab hasn't yet been approved. So you got to finish one completely before you start the code review process of the next one. Questions about those labs? Because this is perhaps unusual.
If we choose to do pairs, are we locked into pairs for the rest of the semester? Or is it
yeah, divorce is a sad part of reality. And so you can certainly, either one of you can leave the partnership at any point you want. You'll both get to have your code up to that point, right? So you both own that jointly. You'll just fork off that. And I can't guarantee that you will be able to find a new partner. But you are not stuck with someone if you don't want to be. Okay, so but worst case, you might have to end up working alone. But you may be able to find someone else who's working alone. One thing to note about this is there are no dates. There are no due dates for the labs. I will post, although it's not posted quite yet, a suggested schedule if you want to finish all 9 labs by the end of the semester. But it's up to you to keep to that if you want to. And so that may mean that if we're at a Wednesday night, 2 weeks from now, as I am moving around from partnership to partnership, some people may be on lab 3, some people may be on lab 2, some people may still be on lab 1, and remotely possible someone could be on lab 4, I don't know. But it's up to you as to how quickly you want to move on this. Part of it as well is we won't have covered stuff in lecture in some cases. We'll have covered everything in lecture by midway through the semester. And by that time, you should have been already on, let's say, lab 5. And so we'll have covered everything you need for the remaining labs too. But there is something that prevents you, let's say, from turning in all the labs the last week of class. Can anyone tell me what that is?
A code review?
Exactly, the code reviews. So I only guarantee to start the code review within 48 hours of when you send it to me. Plus, we've got also the oral interview, which has to be scheduled. So that is going to provide some limitation of how quickly you can turn things around. You may find, as I said, what the code review is going to look like. You know the kinds of things they're going to be looking for. You and your partner can just very carefully look through and make sure everything is good, so that the code review may have just one round trip back and forth. In industry, code reviews are often not, I give you my code to look at, you give me responses, I reply, and we're done. Instead, there's often a back and forth and a back and forth that can happen. So that may very well happen here. And we'll just need to do that back and forth until basically I'm satisfied. I'm not a crazy person, so don't worry too much. Okay. So we've got grading of labs, and they look like that. Note as well, I think I pointed out that there are some challenge exercises in the labs. And so when you turn in a lab, you can also optionally turn in some answers to up to 2 challenge exercises. We'll see that can affect your final grade. Then we have the learning objective bundles. The assessment is, so this is the assessment of a learning objective bundle. So basically, you'll have on Sakai a quiz with some problems that are related to the learning objectives for this learning objective bundle, right? So that assess whether you know that or not. If you get that correct, right, all 100%, then you're done. Cross off that learning objective bundle, move on to the next. Let's not say move on to the next. Cross off that one, and there's one fewer to do. If you don't get 100% on it, then you can retake it in any subsequent week, as many times as you want, but only once per week. If that makes sense. So the assessments are available after particular materials covered in class. So for instance, this Thursday, there'll be some assessments available on X86, for example. There's an assessment bundle for that, and I think GDB will be available. So you could take them this week as soon as you want on Thursday. And if you pass them, great, you're fine, you're done with those 2. If not, maybe you get one of them right, completely right, and one of them you don't get completely right. You can take it again the next week. So there's a little form for you to fill out to take it again. If you don't get it right, you could take it in the following week. and the following week, and so on. In a particular week, you might choose to be taking, I don't know, 10 assessments. That could be, or 1 or 2 or none. It is completely up to you. The assessments are not identical from week to week, so there's some random choices that are happening in that, so you don't necessarily get exactly the same questions. Does that make sense? Any questions on that? Okay, so the final grades are based on 3 items. How many labs did you complete? How many lab challenges problems did you complete? And how many learning objective bundles did you complete? So there's no partial credit for labs, right? It's how many labs did you actually successfully get through? There's no partial credit for learning objectives. It's how many of the 21 of them did you complete? And then for the challenge problems, how many did you complete? Let me show you that table, because that's probably of interest to you. So in the syllabus, all of what I've described about the labs and the learning objectives are covered in here. So we have the learning objectives. We have, for instance, the list of all the learning objectives, which is here. So you can see what all of them are. Some are shorter, some of them longer. You can see some of the objectives, actually, as I mentioned, about halfway through the semester, we'll have finished most of the material about operating systems, most of the sort of fundamental material, and we'll be working then on papers on more advanced topics. So we'll be doing basically a paper per class. And so there are learning objectives I have for each of those papers. We get to the labs. Again, this discusses the code review and everything else. And then here's the grading, basically. It's so for an A, you need to complete all 9 labs. You need to complete at least 8 challenge problems, of which no more than 2 are in any given lab. You need to have completed at least 20 of the 21 learning target bundles. So it just kind of moves its way on down. To get a B-, you do need 8 labs. The 9th lab, admittedly, is a fairly hefty lab. Okay, so it's fairly time consuming. It's writing a device driver for an Ethernet card. 10% fewer of the learning targets. So theoretically, this is not a good idea, but theoretically, you could not show up in class, do the labs, learn the material, pass the learning objective assessments, and get an A. Do I recommend that? In fact, I do not. I recommend you do come to class, and it'll just be I recommend you both come to class and you stay up to date on both the learning objectives and the labs. I can remember as a freshman in college taking a programming class that was completely self-paced, and starting it. So this was quarters. So these were 10-week quarters, 10 weeks plus finals. So starting at the beginning of 6th week, and that was a major challenge and also a major mistake. So there is enough rope to hang yourself. Don't stay on top of it, and definitely do come to lectures. Sorry, you're not coming to lectures. You're watching the lectures online. Come to the in-class activities. Any questions about what we've gone over so far? Kevin? I thought your hand went up, but I guess not. Lab partnerships. So lab partnerships are semi-permanent, right? One can get divorced, but it's sort of like a divorce. It's that, you know, it's that bad. You may get divorced and you may be single for the rest of your CS 134 life. So the lab partnerships I want to have by 5 p.m. on Wednesday. I will provide in class time on Wednesday a Google form link for you guys to fill out to provide me what those partnerships are. The main reason I want that is, of course, 6 p.m. on Wednesdays when we start the lab time, and I want you to have partnerships for that. And in particular, I need them ahead of time because I need to set up breakout rooms, how those break out, and I need some time to do that so that we can separate out during lab time. Again, in class, we have what we call it, one class stands, I guess you'd say, right? Partnerships will just be for the duration of the class, and it might even be 2 or 3 people. So yeah. Anyway, I'll just randomly assign people to breakout rooms to do assignments in class. Lab partnerships. So you may or may not know everyone in this class, and in the section 1 of this class. So what I'd like to do now is just take 5 minutes, especially folks who are not from Harvey Mudd. So what I'd like to do is take 5 minutes, and I want to group people into 15, 14, in groups of, I guess it'll be around 4 is what I'm going to do. Put you in a breakout room for 5 minutes, let you guys chat among yourself, see if there's any, chemistry, and then break you out and put you in another random group of 4. So this can kind of give the simulation maybe of like what we'd have after class in the classroom, where you guys might, chat together and see about finding partners. You can also try and find partners on Piazza. There's a form there to fill out saying kind of, I'm looking for a partner, and that can be effective. So as you're talking, you might want to just keep in mind, what kind of times you work, day or night. You would work well for you working on the labs. So time zones may be an issue for that. Where you're heading for, maybe everyone's going to be heading to get through Lab 9, which would be great. So if you're all heading for Lab 9, then you might have a higher pace than if for some reason you're only going through some fewer number of labs. So let's break out now, and again we'll do that for about 4 or 5 minutes. Okay, the last thing I wanted to do, I know I broke that out kind of quickly, was I wanted to just mention office hours. So office hours, I have quite a few hours of office hours, and the way I'm working that is with a Google Calendar appointment page. So that was back on the syllabus, had this reference to office hours. I do highly recommend you read the syllabus completely. So in office hours, you can see there are various points that you can click on one of these office hours and reserve 15 minutes. Okay, so go ahead and do that. This week, there are fewer office hours than next week. So next week, we have sort of Monday nights, Tuesday mornings, Tuesday afternoons, Friday midday. And so just click on one of those, make a reservation. Any questions that you might have about anything, feel free to reserve an office hour. If I've got a chunk of time and no one has reserved an office hour, I'm not going to just go on Zoom and wait in case someone comes. So if you want to meet, go ahead and do reserve. Even if it's right beforehand, that's fine. Still go ahead and reserve and I'll meet. And if you're there, let's say at 12 o'clock for a 12 o'clock meeting, and no one has signed up for 12:15, we can just keep talking as long as you want to those office hours. If you find that that none of these office hours work, like they're taken in a particular week and you need an office hour, then go ahead and let me know on Piazza and I will open up some more. I think that's it for the day. Are there any questions? I'm really hoping that you enjoy this class. and enjoy the topics and materials as much as I do. So I will see you guys on Wednesday at same time, 2:30. Bye.
Bye. Thank you.
Yeah, you're welcome.
Thanks for our trades.